The next problem. The height of Mount Everest is 8.85 km. Find out the value of acceleration due to gravity at its top if its value on the surface is 9.8 meter per second square. Here, we have to find the acceleration due to gravity at a given height. So, we can use the formula gh is equal to g into 1 minus 2h by r. And we have given the value of h, that is 8.85 kilometer, and we know the value of capital R, that is 6,400 kilometer, and on the surface the value of g is equal to 9.8 meter per second square. So let us substitute all these values here. G is equal to 9.8, 1 minus 2 into 8.85 kilometer divided by 6,400 kilometer. So after the calculation, we have the value of g at a given height is 9.77 meter per second square. Next, two spheres each of mass 50 kg are 30 cm apart. Find the gravitational constant g if the force of attraction between them is 1.853 into 10 raised to negative 6 Newton. Here we can use the Newton's law of gravitation, and we know the formula capital F is equal to capital G into m1 m2 divided by d square. Here we are asked to find the value of capital G. So G is equal to F d square divided by m1 into m2. So we can write m1 is equal to m2 is equal to 50 kilogram, and the distance between them are d is equal to 30 centimeter, that we can write 0.3 meter, and the force of attraction between them are F is equal to 1.853 into 10 raised to negative 6 Newton. So simply substitute all these values. F is equal to 1.853 into 10 raised to negative 6 into d square, that is 0.3 square divided by masses, that is 50 into 50. So you can do the calculation, and after the calculation you will get the value of capital G is equal to 6.671 into 10 raised to negative 11, and the unit is Newton meter square per kilogram square. Now we have the next one. The radius of Mars is 3,380 km and that of Earth is 6,400 km. Find the acceleration due to gravity on Mars if its value on the Earth is 9.8 meter per second square. The mass of the Mars is 1/10 of the mass of the Earth. Here we are asked to find the acceleration due to gravity on Mars. So we have the expression for the value of G. G is equal to capital G m divided by r square. So for the Earth, GE is equal to capital G, that is universal constant, ME divided by RE square. For the mass, GM is equal to capital G, the mass of the mass, capital small m divided by small m means it is a suffix R m whole square. Now divide these two equations. We have Gm divided by Ge is equal to capital G m suffix m divided by Rm square whole divided by capital G m E divided by Re square. That gives this capital G m will be cancelled out, and we have the mass of the Mars m, and this Re square coming to the top, the numerator is Re square divided by the mass of the Earth me, and the radius of the mass square, that is Rm square. Now let us see what are the informations we are given. That is, R is given 6,400 kilometer, and Rm, that is equal to 3,380 kilometer, and the value G on the Earth, that is G is also given, that is 9.8 meter per second square, and we have the ratio. The mass of the Mars is 1/10 of the mass of the Earth. So the m mass of the Mars divided by the mass of the Earth is equal to, what is m? Is 1/10 of the mass of the Earth, that is 1/10 of me. So divided by the mass of the Earth, that is equal to 1/10. So we can substitute all these things. Here we have the ratio Re by Rm square. So it is not necessary to convert into the radius into meter. So let us substitute. It's equal to m, the mass of the Mars divided by the mass of the Earth, that is equal to 1/m, 1/10, and the ratio Re by Rm whole square. We can write Re by Rm whole square, that is 6,400 divided by 3,380 whole square. And also we can express capital GM, GM, that is accident due to gravity on Mars, equal to GE into these values, that is 1/10 into 6,400 divided by 3,380 whole square, and what is the value of G? That is 9.8 divided by 10 into 6,400 divided by 3,380 whole square. So after the calculation, you can find the value of the acceleration due to gravity on the surface of the Mars is 3.51 meter per second square. Now the next one. The acceleration due to gravity at sea level is 9.8 meter per second square. Find the height above the earth where the acceleration due to gravity is 9.7 meter per second square. Given that capital R is equal to, that is the radius of the earth is equal to 6,400 kilometer. That is, we know, here it is the variation of G with the height, and we are given the value of G at the surface and also at a given height, and we have to find at which height this acceleration due to gravity is 9.7 meter per second square. So let us write the value of G on the surface is 9.8 meter per second square, and on the at a height, that is GH is equal to 9.7 meter per second square, and the radius of the earth is 6,400 kilometer, that we have to convert into meter, that is 6.4 into 10 raised to 6 meter. What is the relation between, what is the expression for the variation of G with the height, that is G is equal to, GH is equal to G into 1 minus 2h by R. So let us, we have to find the expression for h. So we can write that is 1 minus 2h by R is equal to G divided by GH, or 2h by R is equal to 1 minus G divided by GH. Therefore, H is equal to R by 2, 1 minus G divided by GH. Now we can substitute the values. That is, what is R by 2? That is 6.4 into 10 raised to 6 divided by 2. 1 into 1 minus G is equal to 9.8 divided by GH is equal to 9.7. So after the calculation, we will get the value of H is equal to 32,900 meter, that is equal to 32.9 kilometer. It is the height where the acceleration due to gravity becomes 9.7 meter per second square. The next, an artificial satellite revolves around the earth at a height 600 kilometer. Find its period. The radius of the earth is 6,400 kilometer. We know the expression for the period of satellite is T is equal to 2 pi into square root of R plus H whole cube divided by small g R square. Let us write, we are given the value of height H is equal to 600 kilometer. Capital, the radius of the earth, capital R is equal to 6,400 kilometer. Now the R plus H is equal to 6,400 kilometer plus 600 kilometer. Now that's equal to 7,000 kilometer. That is equal to 7 into 10 raised to 6 meter. And the radius we can convert into meter, that is we have done in the previous problem, that is 6.4 into 10 raised to 6 meter. Now let us substitute. That therefore T is equal to 2 pi into square root of what is R plus H? That is 7 into 10 raised to 6 whole cube divided by small g we know 9.8 R, that is 6.4 into 10 raised to 6 whole square. So after the calculation, you will get the value of the time period is 1 hour 37 minutes. So after the calculation, you will get the answer in seconds, and that we can divide by 3600. You will get the time period in hours. Next one, determine the escape velocity from the moon given that capital G is equal to 6.67 into 10 raised to -11 Newton meter square per kilogram square. Mass of the moon 7.4 into 10 raised to 22 kilogram. Radius of the moon 1750 kilometer. So in this problem, we are asked to find the value of escape velocity. We know the expression for the escape velocity from the surface of a planet or from the surface of a heavenly body is VE is equal to square root of 2 capital GM by R. Now we have the values. Capital G is equal to 6.67 into 10 raised to -11 Newton meter square per kilogram square. Capital M, that is 7.4 into 10 raised to 22 kilogram. Radius of the moon, that is equal to 1750 kilometer. That we have to express in meter, that is equal to 1.75 into 10 raised to 6 meter. So let us substitute all the values here. That is V is equal to square root of 2 into 6.67 into 10 raised to -11, and the mass of the moon, that is 7.4 into 10 raised to 22 whole divided by the radius, that is 1.75 into 10 raised to 6. So after the calculation, you will get the value of the escape velocity from the moon is 2.375 kilometer per second. The next problem, find out the height at which acceleration due to gravity is half of its value on the surface of Earth. We have to find out the value of the height at which the acceleration due to gravity becomes the value on the surface of the Earth, the half of its value on the surface of the Earth. That is, the GH becomes G by 2. First we have to write the expression for the GH. That is, GH is equal to G divided by 1 plus H by R whole square. Here we have to find the value of height at which the GH becomes G by 2, the half of the value of the acceleration due to gravity on the surface. And we are also given the radius, that is 6400 kilometer, that we can express in meter, that is 6.4 into 10 raised to 6 meter. Now let us substitute the value of GH as g by 2. So g by 2 is equal to g divided by 1 plus h by r whole square. Now this g can be cancelled out. Then we have 1 plus h by r whole square equal to 2. Then what is 1 plus h by r? Taking the square root on both sides. That is equal to square root of 2. That is equal to 1.414. Then what is h by r? H by r is equal to 1.414 minus 1. That is equal to 0.414. Therefore, h is equal to radius into 0.414. That is equal to. So we can express it in kilometer. That is 6,400 kilometer into 0.414. So after the multiplication, we have the answer 2,650 kilometer. That is, this is the height at which the value of g becomes the half of its value on the surface of the earth. Next, a body is projected vertically up from the earth with a velocity equal to 1/4 of the escape velocity. Find the maximum height reached. Here, the body is projected with the velocity is comparable to the velocity of the escape velocity, but not with the escape velocity. It is about 1/4 of the escape velocity. So we are asked to find the maximum height reached, and we are given the radius of the earth. So we have an expression. We have an expression for the height at which the body is reached when it is projected with a velocity comparable with the velocity of the escape velocity. Comparable means here it is not projected with the escape velocity, but with the velocity just in the range of the escape velocity. That is, the body is not capable of leaving the gravitational attraction because it is projected with the velocity less than the escape velocity, but it is not very small. Okay, in that case, we have an expression for the height reached, the maximum height reached by the body. Okay, and that expression is given by u square minus u square into r divided by v e square minus u square. H is equal to u square r divided by v square minus u square. Here, u is the initial velocity with which the body is projected from the surface of the earth. That is equal to 1/4 of the escape velocity. That is 1/4 of v. And the radius is given 6,400 kilometer. That is equal to 6.4 into 10 raised to 6 meter. And we don't have the value of the escape velocity, but we can express it in still VE. Here we are asked to find the value of capital, so value of the height. So let us rearrange and let us substitute. That is u is equal to 1/4v. 1/4v, so 1/4v whole square into r divided by v square minus 1/4 v square, v whole square. So let us expand V square by R. Here 1 by 16 is there. So that is I can express 1 by 16. So 16 will be in the denominator into V square minus 1 by 16 into V square. So again we can arrange V square into R divided by 16 is already there. We can take out the value of the common values, that is V square by 16. So when we take it out, 1 by 16 can be taken out and V square also can be taken out. That is 1 by 16 V square is this are common. So when it is become taken as a common, then the first term we have to multiply with the 16 minus, here we have 1. So we can cancel out this 16, and this V square and this V square. So the remaining, the capital R divided by 16 minus 1, that is 15. When you complete the calculation, you will get the value of H is equal to 426.7 kilometer. 426.7 kilometer. Next, find out the mass of the moon if the acceleration due to gravity at its surface is 1.62 meter per second square and the radius is 1750 kilometer. And we are given the value of capital G, the 6.67 into 10 raised to negative 11 Newton meter square per kilogram square. We have to find out the mass of the moon. So we have an expression for the small g from any planet, that is any heavenly bodies, that is small g is equal to capital Gm divided by r square. From that, the mass of the heavenly bodies, the mass of the moon, capital M, is equal to small g r square divided by capital G. So we have all the values, that is capital G is equal to 6.67 into 10 raised to negative 11 Newton meter square per kilogram square, and the value of G on the surface of the moon, that is 1.62 meter per second square, and the radius, that is 1750 kilometer, that is equal to 1.75 into 10 raised to 6 meter. So let us substitute all these values. G is equal to 1.62, radius 1.75 into 10 raised to 6 square divided by capital G, that is 6.67 into 10 raised to negative 11. So you can complete the calculation, that is 1.62 into 1.75 square into 10 raised to 12 divided by 6.67 into 10 raised to negative 11. We'll just arrange, that is 1.62 into 1.75 square divided by 6.67 into 10 raised to this negative 11 come into the when 10 raised to negative 11 come into the numerator, it will come the 10 raised to plus 11, then the power of 10 becomes, that is 10 raised to 23. Okay. After the calculation, you will get the mass of the moon is equal to 7.44 into 10 raised to 22 kilogram.